For 40 years, robots couldn't do something a 5-year-old does without thinking. Pick up an egg without crushing it. Your hand makes thousands of adjustments automatically. Too tight, it shatters. Too loose, it slips. Your nervous system learned this by touching things, by dropping things, by breaking things. Robots had none of that. No matter how powerful they got, they had no sense of the physical world. Then, just weeks ago, NVIDIA CEO Jensen Huang stood at CES 2026 and said, "The ChatGPT moment for robotics is here." One word, that's all he changed from the year before. Coming became here. The physical world doesn't repeat itself. No two eggs are the same weight. No two grasps are identical. For decades, engineers tried to solve this by writing rules. If the object weighs this much, apply this much force. But you can't write enough rules to cover a world that never repeats itself. You need experience, the kind that only comes from thousands of interactions. Humans have that, robots didn't. So NVIDIA built it for them. Think about what ChatGPT did for language. It didn't memorize grammar rules. It processed so much human text that it built an internal model of how language works. NVIDIA did the same thing for physics. They fed a system called Cosmos millions of hours of video, objects falling, hands gripping, materials bending under pressure. Cosmos didn't memorize what it watched. It built an understanding of how the physical world behaves. So now, when a robot approaches an object, Cosmos can predict what happens next. If it grips here, at this angle, with this force, will it slip, crack, roll? The robot isn't following a script, it's anticipating consequences. This week at GTC 2026, they announced Cosmos 3. Robots can now train inside entire simulated worlds before touching anything real. Figure deployed its first robots inside a BMW plant. Agility robotics machine, called Digit, is being tested inside Amazon warehouses. Mercedes-Benz is running humanoid pilots on its production line in Berlin. At GTC 2026, ABB, Fanuc, and KUKA announced they are now building on NVIDIA's platform. These aren't startups. ABB alone installs more than 100,000 robots every year worldwide. When they move, the industry moves with them. Last year, researchers at the University of Buffalo published a study. They built an electronic fabric that gives robots a sense of touch, not just pressure, but slip detection, the same information your fingertips send to your brain. Between 2022 and 2024, the cost of a full-size humanoid robot dropped 40%. $2.5 billion in venture investment went into humanoid robotics in 2024 alone. Machines have always replaced repetitive motion, welding, stamping, moving identical parts down an identical line. But sorting fruit, handling a fragile component, that required a delicate hand. That protected a $50 trillion part of the global economy. At GTC 2026, just days ago, Huang said,
"In Houston, Texas, Foxconn is building a state-of-the-art robotic facility for manufacturing NVIDIA AI infrastructure systems. With labor shortages and skills gaps, digitalization, robotics, and physical AI are more important than ever."
Companies aren't deploying these robots to cut costs. They're deploying them because the workers simply aren't there. But it's worth being clear about where we actually are. These deployments are still pilots, still supervised, still narrow. The robots do specific tasks in controlled environments, not everything a human can do. The question isn't whether this becomes real, it's how fast. For most of human history, the physical world was the one place machines couldn't follow us. That's changing now. Not because robots got stronger, but because they finally started to understand the world they're working in. As always, thanks for watching. This is Humans Are Changing. If this gave you something to think about, hit subscribe. See you in the next one.